Hello, and welcome back to another episode of Impact Factor. I am your host, Katie Van Aken, and this week's episode features a conversation I had with someone I went to college with briefly, and she's been doing really cool things since, and now she is in a PhD program for computer science and cognitive science. And I hope you enjoy. Here's my conversation with Maggie Perkoff. So Maggie, wow, it's been a long time. 10 years? More?
Yeah. Oh my God.
I graduated
It's been that long since graduating.
11 years?
Yeah.
I know. Doesn't it make you feel old? Well, you were 2014?
I graduated in 2015. Yeah.
2015, okay.
Yeah.
Okay. So tell me, well, I assume based on what I know, you didn't go right into your PhD. So let's do a little bit of like setting the stage here. So what was your major at Haverford and what did you pursue after that?
Okay. So I actually double majored in computer science and linguistics at Haverford. And I was really interested in natural language processing, which I feel like at the time, no one really knew what it was. And it's become super popular since then. It's basically how do you like make applications to help computers understand language. And right after school, I actually got offered a job on what was then a secret team called Speech at Amazon. And it turned out it was Amazon Alexa. So I started working for Amazon Alexa the same month that they had their first public launch. Yeah.
Whoa, that's cool. And you didn't know?
I had no idea. I signed the contract like in October of my senior year. And I was like, okay, they threw out some exciting words like you're going to be working on machine learning and speech applications in a high scale computing environment.
All
like,
the buzzwords. Yeah.
I need a job. Yeah.
That's cool. Okay. So you went right into industry. When you were at Haverford, did you do research as part of your program?
Yes. Haverford has all of their students do undergraduate thesis. And I also spent a summer doing research with my advisor, JD, John Doherty, in the computer science department. So my summer research was actually focused on technology for the deaf and hard of hearing, and what that assistive technology domain looks like. And my undergraduate thesis was actually on programs for sign language recognition. So kind of combining that assistive technology focus along with language processing and sort of what are the nuances of sign language that can make it harder for a computer to model than verbal language.
Whoa. So was it kind of like image processing? Because you were like, it's not spoken language, it's like visual, right?
Yeah. So computer vision is its own field, which is really interesting and I know nothing about.
Nice.
So I was focused on if you can imagine that you had a text representation of what you saw in a video. So maybe it's telling you that a hand has a certain number of fingers up versus down, then how would you actually interpret meaning from that? So I was sort of skipping over, because again, this is an undergraduate thesis, skipping over the whole like vision algorithm element and really focused on like interpreting meaning from each of those almost like frozen frames in time.
That's cool. Because like you said, it's kind of filling the gap that is left by computers trying to understand something a human is doing. And so you're filling that gap with like how would we describe what the human is doing and what does that mean? That's cool.
Yeah.
Very cool. Very cool. So what did you think about research at that point? Were you like a fan? Not a fan?
Let's see. I At the time, I enjoyed the research in the sense that it was really fascinating to learn more about like the like deaf community and understanding like the differences in cognition and language understanding. And also just learning about the fact that regardless of the mode in which you communicate, as long as you're exposed to a certain amount of language, that's the number one indicator of like later education and reading comprehension success.
Oh.
But I got most excited about, I think, writing code for the thesis. And at the time, I think I thought that doing research meant like, oh, all you're doing is reading papers and talking about the theoretical. I didn't really understand the concept of applied research. So I was like, oh, this is cool. It was fun to learn about this stuff, but I want to build something. Yeah.
Yeah. Yeah, no, that's a really interesting perspective, and I think it's probably pretty common from an undergraduate perspective. You know, you're tasked with writing this thesis and doing this project, but you don't really grasp the whole PhD vibe.
Yeah.
Yet. Okay, so what happens next? So you go work on Amazon Alexa. Super cool. What was that experience like? Or was it cool? I don't know.
So, it was definitely cool. It was almost it was definitely overwhelming at first, starting as a software engineer right out of college at 21. And as it's become this massive organization. But when I started, it was super early on. So I was getting handed a lot of responsibility right away, which was both fantastic and terrifying. So I had a lot of opportunities to like have a meaningful impact on the project and get to see. I spent a lot of time working on some of the infrastructure that made it work when we first launched in languages outside of English, which was really cool to see. And I learned a lot on the way. But I think it was also this crazy transition of going from, okay, there's always a teacher telling you how to do something, or an upperclassman or someone else who's going to guide you on the way, to, hey, by the way, we're going to be trying to launch German in 3 months from now. And we only have this team of people here, so everyone's going to need to do a lot right away. So, yeah.
And at that point, you're writing code, like you're implementing the German version at that point?
Yeah, I was implementing the infrastructure for German. So I worked with a team of research scientists that were building out the individual language models. And then my team's job was basically to make sure, like, can you make these files available on different devices? And also, like, data privacy is a major concern. And I think there's been a lot more like legislation now in the US, but in Europe at the time, they had much stricter data privacy standards. So being able to make sure that like all of your file storage is compliant with legislation, it's not something you ever deal with in a classroom.
No.
Very important at like a big scale tech company.
Yeah, you cannot avoid it with a tech product these days, right?
Yeah.
I'm sure that was probably really useful, you know, just for your career trajectory to be exposed to that too, because that only is going to has gotten more serious.
Yes, it's very true. Actually, fun side fact, and you can exclude this from the podcast. Terrell Friedler is a professor at Haverford who is actually being consulted for the data privacy legislation for the White House. And so they just released like a new like sort of AI constitution talking about like what does data privacy mean in the United States. And there's a Haverford professor who's like leading that charge, which is kind of amazing.
It's like a committee problem, and they're like, wow. Yep. How do you know that? Are you just in the CS
there's an
world?
alumni group for Haverford CS.
Cool.
And so
I should see if my brother knows that. I think he was in your class, Adam.
Oh yeah, he would definitely know. Yeah.
Yeah, that's cool. That's very cool.
Yeah.
We can talk more about that later because I have some
Sorry, that was
questions. No, it's very cool. Very cool. Okay, so a lot of responsibility, a lot of kind of intense industry experience in the coding world. What was your trajectory like, I guess? Did you stick around in the same space, different job roles? How long were you there?
Yeah. So I did actually stick around at Amazon for 5 years, which is a pretty long time by tech standards. It's a pretty fast moving industry. So a lot of people do tend to like jump between companies and roles. I stayed in the larger Alexa organization the entire time. Just with the way that the company expanded, though, I did end up on different teams. So originally I was on a team of 5 people, and we're the only 5 people doing this model storage for the entire device, which obviously wasn't going to work long term. And so, first we split into 2 teams and they split us up, and they kept wanting to like keep the people who were there originally, like making sure there was one sort of more quote senior person like on each of these teams. And so sure enough, I think within 2 years, I was the only like quote senior person on a team, like after coming in, being thrown into the fire. And it's like, well, we need someone who's been here for the last 2 years to sort of lead a team. And so that kept happening, which was kind of funny to then be like 2 years in at 23 considered like a senior person just in terms of having been there for a while. And I did get promoted to being a software development engineer too at Amazon. And ultimately decided to switch into a different part of the organization. Because at that point, after I guess 2.5 years, I was kind of interested in finding out like about a different part of the company. I'd been working on like infrastructure and model storage. And I moved to a team that was doing contextual carryover, which basically when you ask follow-up questions that use an anaphor. So if you say, Alexa, what's the weather in Boston? How about Seattle? It's an intent carryover. It knows that you still want the weather versus if you're saying, Alexa, play Adele's latest album, give me something else by her. And it knows that her is supposed to be Adele.
Oh. Yeah. So those are 2 different situations because you said her or no, they're the same.
So they're 2 variations of the same problem.
The same problem.
It's either like intent carryover, so both times you want the weather, or what's called slot carryover. So you refer to Adele and then say her. Exactly.
Yeah. Got it. Cool.
Yeah.
The things you don't think about when you're just like using your Alexa, right?
I know.
You just use it and you're here being like, I know why that works. Okay, so that's like a whole nother division then, or like group? Okay.
Yeah, so that's a different part of the Alexa organization. So different management chains from model storage. And it was just cool to see how like different features worked and like how much nuance there was there. Yeah.
And always good to move around and meet new people and work with new people, right?
Yeah.
Definitely keeps it interesting. So then after your time at Amazon, what was next?
So I started my PhD in August 2020. I guess my last day at Amazon would have been July 1st, 2020. Okay. So it was not a ton of time off in between. Yeah. But I started my computer science PhD program, which has since turned into a dual degree program in computer science and cognitive science.
Yeah. Oh man, we're going to get to that. I didn't realize that. That's so fun. Cool. Okay. But first, I want to talk about your decision to go back and get your PhD.
Yes.
What led to that decision? The floor is yours.
Okay. So as I said before, about like 2.5 years in, I was starting like to try to find something new, and I wanted to learn something new, and I wasn't quite sure what that meant yet. So I did switch teams within Amazon, but I also started considering grad school and maybe like learning a bit more in depth about like how some of these language models worked. So I had been in language processing in undergrad, and then I ended up in this infrastructure role where it was my job to talk with all the people who are creating these incredible language models that help figure out, like, based on whatever request you just said to your Alexa device, how do we actually route you to the correct underlying system? But I wasn't touching any of that. I was just kind of the person packaging it up and making it available.
Yeah.
And I was really curious how those worked. So first, I thought about doing a master's part-time. And like, I'm kind of laughing looking back at this now because I applied to have graduate non-matriculated status at the University of Washington. So basically, I could start taking courses, and then if I decided to apply to a graduate program later, all my credits would count.
Gotcha.
And so I decided to take syntax for computational linguistics at the University of Washington while I was still working full-time. So I made an arrangement with my manager where twice a week I went into the office at 7 a.m. I worked from 7 to 3 p.m. and then I took a bus over to UW and would go to class for an hour and a half on campus and then bus back home. And we had homework assignments that were due every Friday at midnight. So that meant that like every week, like I'd still be coming home and doing my normal work schedule and also making sure my assignments were in. And on the one hand, I started to realize, wow, I miss using my brain in this way and really diving into some of like these more complex algorithm concepts as opposed to being on the infrastructure side of the world. But also, I don't think I can do this while working full time.
Yeah.
And so it sort of kicked off this year-long process of talking with people who were in graduate programs, talking with professors, like, you know, cold emailing people at the company who were in research roles that I thought that I might want to have someday and asking them what their background was. And like then ultimately doing a lot of research on what programs were even out there that I'd be interested in.
Yeah. That's like a full-time job in itself to like interview all those people and do your own research and figure out what's next, right?
Yeah. I was pretty tired. I was
yeah. You were still young then, right?
Yeah, exactly.
Yeah. That's fun. It's kind of funny to look back and be like, how did I do all of that at once, you know? And be like, I couldn't do that now.
No idea.
I feel the same. Okay, so you were taking classes and working, and you were like, I can't do this both. And eventually, your conversations with people led you to the PhD over the master's. For any particular reason?
So, I definitely went into the research thinking, oh, I just want a master's. That sounds like way too much school. I'm never going to do a PhD. And so I'm talking with people and I find out that there's a few research scientists at Amazon that have masters, but a lot of them do have PhDs. And then I start like really trying to dig into the programs, you know, using the very high-tech method of Googling best language processing computer science master's program in the US. And
you can ask your Alexa that and see what happens.
Exactly. And I kept going through like the course offerings and realizing I really liked research-based master's programs. And I really liked also this weird combination of classes that didn't fit within the credits of a master's program. So basically you had a certain number of distribution requirements, and then you could take a few, like most programs call them elective classes. And I just kept thinking, I was like, well, this isn't like enough. I'm not actually going to get to learn the things that I want to learn. I want to do more of this. And finally, I ended up actually going to the Grace Hopper conference, which is like the world's biggest computing conference. It's all women in Florida. And I was I was there on behalf of Amazon. Like I was sent as part of a recruiting trip. And I had some free time. And so I decided to go over and talk with like all of these school booths that are set up. And I think I was actually talking with like the recruiter from University of Washington and telling her like I'd been looking into this master's program that they offered and just saying like I feel like I can't fit in these classes, this isn't right. And she said to me like, is it all right if I tell you something very honest? I don't think that what you want is in a master's program. It's in a PhD. And the only reason you're telling me you don't want to do a PhD is you're scared of the time right now. But you're also trying to cram in a bunch of things to a time frame that's just not going to work. And I mean, I think I had a few friends in PhD programs who wanted to say that to me, but maybe I wouldn't have listened to them because I was like, no, you're in a program. Like, you just want me to do what you're doing, whatever else. And like having this like random person at a conference, like just kind of objectively look at me and be like, these are the facts. This is what you're asking for. This is not containable in a master's. Yeah.
That woman sounds like she's very good at her job. Like
she was
after
great.
one conversation with you, she was like, here's what you need to do.
Exactly.
I need to talk to her. She sounds wonderful. And also too, I imagine, I don't want to put words in your mouth, but I imagine there was some hesitation because you had already worked for 5 years and the feeling of going back to another 5-year school experience was overwhelming.
It's definitely scary. There's no doubt about that. I also kept thinking, I was like, I'm too old for this. There's no way. 5 years definitely felt like a really long time to be out of school. I think one of the hardest parts of it when I first transitioned to being a student again, I had to effectively teach myself linear algebra at one point. I'd figured out at Haverford what was the bare minimum of math classes that you need to get a degree in computer science.
You're one of those CS people.
Yeah, that's what computers are for. They do all the math for me. It's great.
Well, so fun sidebar. So I just read an article that said that they did a research study that said that students that are really good at math that doesn't necessarily translate to being good at software development because actually it's your ability to learn languages, which makes sense. And actually, it was really validating for me because growing up, I was always really good at math, and my parents were like, "You should become a software engineer," and I was so bad at it, I can't do it. And I'm also bad at languages, so it's like I was like, "This is finally makes sense to me," you know? Because you're talking to a computer. That's what you're doing. You're,
It's a really good way of putting it. Yeah.
Yeah. So sorry, off topic.
No worries.
We were talking about. So you didn't want to take math, so you had to relearn linear algebra because that was part of your grad program?
It was part of a first homework assignment for the machine learning class at CU Boulder, which, that was like the thing that I really needed to do. It's kind of foundational to everything in language processing now. And the first week there was a homework assignment that was all linear algebra. And I started watching Khan Academy videos and going through every like online YouTube tutorial I could.
Yeah. So let alone having to like really learn how to do homework, you're like doing homework that's like a subject that you intentionally didn't learn.
Exactly. Yeah.
Yeah. Stressful.
Yes.
Um, wow. Okay. So, but you made it through. You've been there for a few years now, right?
Yep. Yeah. I'm
Um,
a third-year PhD student now.
third year. Very cool.
Mhm.
So I want to ask you about what you're studying or what your research is on. But
Mhm.
before we get there, I want to ask you um, what your program is like as far as like the balance between students who are coming right from undergrad and students like you who are coming from industry. Did you experience a difference there or a balance?
Yeah. I was actually really surprised to find out it's about half and half, at
Mm.
least in the computer science department at CU Boulder and in the cohort I'm in. We are a pretty large cohort, though. Computer science is one of the biggest departments. So I think that we started out with about 36 of us. And,
Oh, wow.
um, a good number of people have worked for at least 2 years between school and then going to a PhD program. And several other people had actually spent 4 or 5 years in industry.
Interesting. I wonder if that's because, well, I don't know. I don't know. But I think that happens a lot in like engineering disciplines because it's useful to experience the working world to decide what you want to specialize in. But it's good because I think you end up talking to people in your cohort that are in both worlds and or both have both sort of paths, and they
Yeah.
bring different, experiences to the same PhD challenge,
Mm-hmm.
Um, what so when you first start your program, um, CU Boulder, you said, right?
Yep.
So do you have qualifiers or what's the process like to become what you are?
Yeah. um, so it's different for every department at CU. And like some of the labs do it slightly differently. I actually just took my preliminary exam in the fall,
Oh,
and so
you
that's
passed.
like
Congrats.
I passed. I passed. I
Yeah.
should clarify that. I passed my preliminary exam.
Nice.
Great. Um, and so effectively, the way that my lab group likes to do it is you are picking a broader topic that's hopefully related to what your dissertation will be, and you do the literature review portion. So your prelim exam is a paper and presentation where you're surveying what is the current state of the art in a particular language processing domain. And you select 3 of your committee members and present it to them. And so I passed that. Yeah.
So what's interesting about that is you said that's how your lab does it.
Yeah.
So you're in a natural language processing lab,
Yes.
or were you admitted to the program as a member of that lab?
Yes.
Okay. Because some programs and people that I've talked to, they come in, they do rotations, which is a
Yeah.
whole different way of doing things. But what do you think about what was their benefit to jumping in right into a lab that you like?
Um, See, I think that for me, it's helpful because, like, and you were saying this about what is the difference maybe of like having time in industry first. I had a pretty clear idea of
Hmm.
what was the subfield that I was interested in going into the program. Um, and natural language processing is very different than being in theoretical computation. There's, you know, and it's not to say that you end up being totally isolated from the other labs either at CU. Like they do a pretty good job of if you want to be collaborating with other professors, you can. But you sort of get right into this is my focus and I am surrounded by people working on these type of projects.
Yeah.
Yeah.
Kind of hit the ground running as far as like research and publications go, even.
Yeah.
In theory.
In theory. Yeah.
Question, is that you're in the computer science department?
Yes.
Okay, I imagine that that's pretty broad. Like,
Yes.
what are some of the different subcategories, just out of curiosity?
Ooh. Let's see. So one of the labs is like theory of computation. So those are for the people who are really good at math.
Yep.
And they're basically proving why everything we do works. It's not all just magic. Um, there's high performance computing is a really big field right now. So as we're using more and more data for computer programs, like how do you make sure that it can actually run in a reasonable amount of time? Let's see. There's a whole like emotion and cognition lab as well. And so they actually do a lot of studies where they're using fMRI machines and eye scanning devices to try to basically model your thinking processes. So they might be looking at if you're reading a text passage, if you model where the eye is moving, can you get an understanding of what words someone is focusing on? Yeah, so
cool. I just interviewed someone.
Yeah.
Oh, robotics. Yeah, I just interviewed someone who's in a neuroscience program, and that's like the other side of that is like the like the biology of the brain versus the computer science part. That's very cool.
Yeah. Well, that's. I think I mentioned this. Sorry to interrupt. So I'm in the dual cognitive science, computer science.
Yeah, I was just going to ask you about that. Do you get to collaborate with them?
Exactly.
Cool.
So the way that CU Boulder makes it work is they have like departments. So there's computer science, there's psychology, there's neuroscience, and then they also have institutes which are meant to like encourage people from the departments to collaborate. So cool. I am part of the Institute of Cognitive Science, and you can get a dual degree in whatever your home department is and cognitive science. They also even offer a triple PhD in computer science, neuroscience, and cognitive science. So, which I think 2 people who have done it. It definitely takes longer. You're going to take a lot of courses. And then really the whole thing is it culminates in this interdisciplinary thesis that shows, you're in some way mapping from like what is the neurological process behind a phenomenon, how do you model it at a computational level.
Wow.
So, yeah.
Very cool, very important though. So it's kind of cool that CU Boulder is promoting that kind of interdisciplinary work with these programs, because it's the intersection of those fields is where we're going to solve the current problems, right?
Yeah, it's a huge part of why like I applied to Boulder and why like I knew I was making the right decision coming here.
And you like hiking?
Yeah,
like hiking? Yeah.
It's not a bad place to be outside.
Yeah, everyone I talk to who's out there loves the outdoors. We'll get to that when we talk about your hobbies. Okay, so tell me about your interdisciplinary research that you are pursuing.
Let's see. So right now, and for the past several years, I've been part of a larger NSF project called the NSF Institute for Student AI Teaming. So basically our ultimate goal is that we can help design conversational agents that can act as an assistant both to teachers and students in the classroom. So.
Whoa.
Yeah.
Wait, okay, tell me more about that.
Yeah.
So, wait, say it again. So teachers and students?
Yes. I like to clarify that because there's a huge importance to creating like technology that can effectively make a teacher's life easier. Like, I think teachers have always been this like bedrock of global society. I think the COVID-19 pandemic has only like emphasized just how critical they are to how everyone functions and how overworked they are. I think that there's a lot of ways that technology can be used to make teachers' life a lot easier. However, there's also a lot of concerns about the amount of stress that students can be under. There's also a lot of concerns about like trying to create more equitable classrooms and being able to like make space for non-traditional participation methods. And like to clarify on that, so one of the things that we've looked at is we're working in middle school classrooms, specifically STEM classrooms right now in Colorado. And we're looking at how a conversational agent could be beneficial during small group work. So if you imagine the teacher says, okay, and now we're going to break up into groups of 4 and work on an assignment. And you could effectively have like a little Alexa or Google Home or whatever it is on your table. And so in that way, it's not just assisting the teacher because the teacher can't be present in every group at once. You're also hopefully like you're assisting the student. You want to be providing feedback to them if they're brainstorming, and also trying to make sure that everyone's participating in the conversation. There's always going to be people who feel more comfortable speaking up in the classroom and sharing their ideas. So one thing that we've talked a lot about is how can like technology act as this community builder, and basically you try to bring people in, and say like, oh, like, Katie, what are your thoughts on this? If you notice that, oh, this student hasn't spoken at all in the last 10 minutes because these 2 children are the only ones that are talking in this conversation.
Interesting. And it's possible to do that in like an automated way? Like,
yes.
Wow.
We're not great at it yet, but we're working on it.
Well, I mean, I think about Siri, and Siri keeps the conversation going. Like there's certainly some benefit. Well, this sounds like a much more useful application of that technology too, Wow, that's super cool. So the technology it's not separately helping the teacher and the student, but it's sort of a combination of something that improves the experience of both parties in the education system.
We have a few different threads going. It is a pretty large institute. I think we're up to over 50 members now from over 10 universities across the country.
Oh, cool.
And like last year, one of our big accomplishments was putting together an end-to-end teacher dashboard. And so it basically like through a pretty large team consisting of different people in engineering and education and collaborative psychology experts. We have a portal where basically you can record a classroom in real time, and it will analyze the small group conversations going on from each of these devices and then provide a dashboard to the teacher to get a sense of like what is the distribution of student speaking time, as well as what are the key vocabulary terms that are coming up. And so that was kind of the goal of last year of just like, can you identify what's going on in the classroom? And now we're switching to the stage of, okay, now that we know what's going on, how and when should we intervene and what does that look like?
Gotcha. Yeah. So instead of the passive monitoring after the fact, how do we actively participate to improve the experience
exactly
in real time?
Yeah.
Cool. Very cool. You know what that makes me think of? And sorry for making this parallel, but they have this new technology that I know of as a soccer coach where they record the whole game, and there's a lot of kind of machine learning that goes into basically picking out all the players that played and like who fouled and who did all these things, right? And you're just like, oh, this would have been useful to know 10 minutes in instead of after the game, you know? So it's the same thing where you're like monitoring and you're evaluating after the fact, but then the next step is like, how do we get that information into people's hands urgently?
Yeah.
Very cool. Wow, I'm excited to see where that goes. Very cool.
We'll see.
All right, so before I jump to my final 3 questions, do you know what you want to do after your PhD? You can say no.
No, I've been trying to explore options. I feel like going back to the just like meeting with people, shadowing people in different positions and trying to figure out what those options are. Yeah.
What are those for our listeners? What are those? How do you initiate those conversations? Are they mostly warm connections that you have already?
It's a mix. I think one piece is I have 2 advisors and they're both super supportive and very willing to like introduce me to people they know. Mm-hmm. And honestly, I think that's like one of the main ways that anything gets done in a PhD is your advisor saying like, oh, like you're interested in that. Let me introduce you to this person that I already know is working on that. And they'll be able to give you more insight than I can. Yeah. And like, that's a super easy like transition point to go from. Like I've definitely considered what it would look like to work in a classroom setting. So I've been talking more with some of the people who are on who are education experts. They're either pursuing their PhD or have a PhD in education, and getting a sense of like, just the fact that in most school districts now there is a dedicated technology team. And so kind of considering what would it look like if, you know, I was on the technology team for the Boulder Valley School District, and what does that actually mean? And again, I think that helps because it's people that, even though I'm not directly working with them on that larger project, we have some connection through the project. And so they've been open to that. There have also been a few times that I've cold emailed people, and I found at least across the worlds of both assistive technology and education technology, people are pretty enthusiastic about, you know, sitting down and having coffee with you. Like I, in addition to some of these ed tech teams, I've also looked into what does assistive technology look like in classrooms. And when I cold emailed, like, cause I just, you know, did a internet search of who is the assistive technology team for the Boulder Valley School District. I got a response pretty quickly because, you know, in these kind of fields, they're pretty niche and they genuinely want people and care about seeing you succeed. So the cold email strategy works pretty well there.
That's a good tip. That's a good, especially in an area like that where there's a lot of passion that drives people's, you know, their jobs are based on their passions, which is great. I also think that it's good that you're doing that earlier rather than later in your time as a grad student, because then it doesn't feel like you're just kind of forcing all those conversations at the end, right? You're going to learn along the way. Very cool. Okay, last question before we go to the final questions. What are your hobbies? What do you do outside of research?
I do a lot of trail running and actually a volunteer ski instructor. And I like to crochet.
Really?
Yeah.
That's very calming, I hear.
It is. This is going to sound really funny, but because I'm in language processing, and I'm not sure if this is an experience you've had, you spend a lot of time where you work hard on a model training script, you hit a button and then you have to wait like 12 hours for anything to give you a result. And so I find I do a lot of crocheting during that time that I'm like, well, I'm training a model. So
yeah,
I just
it's very
finished
productive 12 hours.
It's great.
Yeah. You finished a sweater?
I made a sweater. Yeah.
Wow. Impressive. And you run around in Colorado. That makes sense.
Yeah.
You played lacrosse, right? Do you still play lacrosse?
Yeah. No, I don't play lacrosse anymore.
Yeah.
Sadly. Although I do fondly sometimes see like the CU team practicing. So now I just run, which is hilarious because I feel like I hated running when I played lacrosse.
Right? It used to be like our sports punishment was running.
Exactly.
And now we are running all the time.
Yeah.
That's great. Well, I always like to ask people that because I feel like it's good to reflect on like, what do you enjoy doing when you're not doing PhD stuff, which is like almost all the time, right? Yeah. Is your dual program going to take longer than 5 years?
Hopefully not, actually. It did mean that I have to take coursework longer than most people do. So I'm in my 3rd year and I am currently taking 2 classes, but then I'm completely done. And I'll have my computer science master's at the end of, I guess, technically I completed all the requirements last semester, but with paperwork, it comes in the spring. But then I've been in the position where I've actually had a research assistantship since I started. And so I think that's given me a bit of a head start on the research part. So I think I'll hopefully be out in 5 years.
Nice.
We'll see.
I have no doubt. I wish you luck, but I have no doubt.
Thank you.
Okay, so the last few questions that I normally ask people start as follows. One is, what is something challenging you faced? And I guess for you, we talked about the linear algebra thing, so that can be your answer if you want. But something that challenging you faced when you transitioned back to your PhD program.
Yeah. I think I'd actually go with learning to prioritize your time can be really hard. I think the balance between coursework and research, and also the balance between larger research projects and specific things that you're interested in. So being on this massive NSF grant, there's always going to be work that needs to be done that may not be my primary focus. But then what I found is that like I kept pushing off, like, especially when I think about the work that then became my prelim exam, it was really easy to be like, well, there's no deadline for this. It's just me that's waiting for this. It's just me that has to write this paper for the department. And I think that like it helped a lot that I have a super solid cohort support system, that I had other friends doing their prelims, and we started saying, okay, this is dedicated time that I will only focus like on my prelim work. So I think learning how to prioritize for that kind of work, like no one's going to make time for it unless you do.
Yeah. I mean, that's the individualized experience that is a PhD program, right? It's like, it's on you. So
yes,
that's
100%.
good. I hear that a lot, by the way. You're not alone. That's one of the challenges.
Yeah. If you figure out how it works, let me know. It's
working on it. Having enough conversations, I feel like I'll get somewhere. So this might tie into my next question, but it is what advice you'd give yourself in the first year.
Let's see. I would just say everyone's on their own timeline. Don't compare yourself to everyone else. It's crazy to see how within my own lab, within my cohort, everyone's in totally different places. Like, not everyone has a research assistantship right away. Not everyone's on a research project that like you can publish from. So if you get to the end of the first year and you don't have a publication, there's nothing wrong with you. Like, it's right. It's just everyone's on their own timeline and going through their own journey. So all you can do is like focus on yourself in that way.
Yeah. That's great. That's really good advice. Hard to do. Good advice.
Exactly. Yeah. It would be great if I could follow that.
Well, I'll put it in my post for your episode, and you'll always have that memory to go back to.
Oh, thank you.
Okay. And then my last question is, do you have a good memory, a fun story to share about your time as a PhD student?
Oh, yeah. I was thinking about this, and let's see. I think the one that really stands out is one of my good friends is Scal Wren in my cohort, and we did a project last year where we built something that would check Google Maps traffic real time, as well as different ski mountains snow reports, to tell you what was the optimal choice to go to based on maximum snow adjusted for minimal traffic.
Minimal traffic.
Yeah.
Oh my gosh.
But we recorded, like, you had to submit a final project demo and video, and we recorded the entire thing wearing ski helmets and goggles and actually sent that to a professor. So that was pretty great.
Was it appreciated? Your artistry?
Yes. Yeah.
That's great. That's good. See, that's nice thing about grad school is you can kind of just like anything goes, right?
Yeah.
Anything goes.
Get creative.
Well, get creative. Well, I love that. That's great.
Yeah.
All right. Well, anything I missed? Anything else you want to shout out? Anything you want to plug? Do you have any papers coming out?
Let's see. We do have a live demo, like that I can like share with you, and
yeah, I'll put it in the yeah. That's great.
Yeah. So it actually won like the best interactive demo at AI and Education last year. So that was pretty cool.
That's awesome. Okay. Well, everyone check that out. It'll be in the link. The link will be in the notes. Check it out. And Maggie, this was really fun. Thank you so much for your time, and thanks for coming on and telling your story.
Yeah, no problem. Thanks for having me and encouraging people to pursue and hopefully stick with grad school if that's right for them.
Thanks to Maggie for coming on the show. If you or someone you know wants to be interviewed on Impact Factor, feel free to reach out via Instagram and follow us for updates at Impact Factor Pod. Thank you all for listening and have a great week.